I am so excited that you're interested in common method variance. I'm your host, Janice Cretion, and I'm a proud member of the 2016 doctoral cohort at the University of Texas at Tyler. This is CFA Marker Variable Technique, a pedantic guide, and the objectives of this workshop are to give you an overview of common variance, to provide you with a step-by-step guide to the CFA technique, demonstrate the models in Amos, discuss analyzing data, interpreting data, and reporting your findings in your study. So common method variance is an issue because it can increase or decrease the observed relationships between constructs, leading to type 1 and type 2 errors. So what is common method variance? Well, it's variance derivable from research design or data collection, rather than the constructs the instrument intended to measure. And reflect on that for just a moment, because research design and data collection, as the researcher, these are things that I have control over. I make decisions on the research design and the data collection. So I should know before I get to deep into my research if common method variance is going to be a limitation to my study. And common method variance is an issue in psychological and organizational data collection, which means that it's an issue for human resource development. And as a quantitative researcher, for reasons and practices that we tend to use that could create common method variance jump out at me. And those are that we use self-report methods and that we collect data for all of our variables from the same source. Item characteristics such as clarity, scale format and anchors, reverse coded items, survey constructs that generally measure the same thing. Also, item context is an issue. Item context includes priming effects, which is asking a question in a way that may lead the subject to answer how he thinks that the researcher wants him to answer rather than truthfully. Item context could also include context-induced mood, intermixing items from different constructs on a questionnaire, and even scale length. And then method effects, which could include the time and location of the measurement and the use of a common medium such as the interviewer characteristics, expectations, and verbal idiosyncrasies. So using a marker variable adds rigor to your study. And as I mentioned earlier, I'm gonna know if common method variance is gonna be an issue before I collect my data. And I believe that as the researcher, if I know that common method variance is going to be a limitation to my study, then a marker variable should be included in the design and data collection. And a marker variable is going to be theoretically unrelated to substantive variables, and it's expected that the marker variable and the substantive variables will have no correlation. Substantive variable may be a new word for you. These are simply your independent and dependent variables from your structure equation model. We've just going to call them something different here because that's what statisticians do. So choosing your marker variable. The cited journal article at the bottom of the slide, Simmering et al., is a good reference for making a marker variable choice. And again, I believe that I need to be able to explain why I chose the measure that I did. I chose blue attitude for my study. And I did that because the preference for the color blue is not theoretically connected to my 4 factors: inattentive, hyperactive, resistance to change, or intent to stay. And I was also intrigued by the blue attitude measure because it was intentionally developed to be used as a marker variable. And I felt it fit into my survey design because it is a 5-point Likert scale. Common method data analysis techniques. And staying again with my beliefs that when there's many, and there are many techniques that can be used to detect common method variance, I believe that when I choose the one I'm going to use, I need to be able to support why and explain to my reader why this was the best technique for my study. Otherwise, I'm being vague, and if I'm vague, my reader isn't going to trust what I've done. So I chose the CFA marker technique for my study because my research design was structural equation modeling, and originally named latent variable marker in SEM, which is very clear, Williams et al. Renamed that the CFA marker variable technique. So it fits in structure equation modeling, so it fit into my study. Also, when an ideal marker is considered, it accurately detects common method variance 84% of the time in the CFA technique, as opposed to 41% and 69% with some other techniques. And so what is an ideal marker? An ideal marker is defined as being chosen a priori, theoretically unrelated to substantive variables, but similar in content and format. And I felt I could support blue attitude as an ideal marker. I followed the recommendations of Williams et al. And Schuck, Nyman, and Zigmori, pages 99 and 100 in my study. So let's talk about the models real quick. There are technically 5 models for the CFA marker variable technique, but at the recommendation of Dr. Nyman, a 6th model is included in this guide. The models are CFA, baseline prep, which is the model that was recommended by Dr. Nyman, but will not be reported in my final paper. Baseline model. Now, there are several steps and multiple paths that are going to be drawn through the whole CFA process, and there are the most steps, I believe, are between the CFA and the baseline models, and that's why the baseline prep was added. It's just a precaution to make sure that I'm executing everything properly, rather than getting all the way down to my 5th model and realizing I have a problem and having to work backwards to find where I've missed something. We're going to be doing these one at a time and putting the data into a worksheet where we can check to make sure that we're tracking properly. After the baseline model, my 3 main models that are going to answer my questions for me. The first one is method C. It's a constrained model, and this model will tell us if we have common method variance. Then we'll run method U, which is the unconstrained model. And this one will say if there is common method variance, is it the same across all indicators? And then we will finish, hopefully, depending on what our method R tells us, with the restricted model, which will say, okay, if there is common method variance, does it skew the relationship between my substantive variables? I'm going to talk rather quickly through the 6 models because I'm going to take you to Amos and work through those live with you, but I believe you will have a better understanding if I at least give you some background on what the models are and what we're going to be doing before we get to that point. So your CFA marker variable technique is going to begin with the measurement model from your SEM. If you respecified your measurement model, that is the model you're going to want to begin with. You're going to add your latent marker variable items and errors, which I've circled for you here in red, and make sure that you name your errors. You're going to correlate your factors. Your substantive factors were already correlated from your measurement model. So what you're going to do is you're going to correlate your marker variable to your substantive variables, which I have highlighted in red for you. And make sure that the variances on all factors are set to 1. All factors meaning your marker variable as well as your substantive variables. Run the model and set the decimals to 10. Since you're going to be pulling data from your CFA model and using those, the output to fix weights in future models, it's important that we have a large number of decimal places for accuracy. We're going to copy and paste the unstandardized regression weights and variances from your output into the worksheet that is titled CFA from CFA, and that's in a workbook that we have provided. And again, it's very important that you have the 10 decimals. So when you copy and paste into Excel, double check that your Excel did accept all 10 decimals. It's possible that you'll need to make an adjustment to your column so that it will accept 10 decimals. And you want to enter the fit indices into the models worksheet. This is just a screen print of the analysis properties we're going to be using so that you have that for future reference. The second model in our technique is called the baseline prep. And the baseline prep is a brilliant model that Dr. Nyman came up with to help us check to make sure that we're not missing any steps in the process. And so we're going to take the CFA model and we're going to build on it by fixing the marker variable regression weights of each marker variable item to the values from the CFA output, which I've highlighted in red for you right there. And then we're going to fix the marker variable variances of the errors of the marker variable to the values that we obtained in the CFA output. And also while you're here, go ahead and confirm that the regression weight for each path from your marker variable item errors to your marker variable items are still set to 1 and that those didn't disappear somehow, which has happened to me. Run the model and enter the fit indices into the models worksheet in the workbook that we have provided. And you're going to see when we go out to Amos and start working with that workbook that we have, Dr. Nyman has put in a little worksheet to help you check to make sure you're not missing any steps. And so that worksheet tells us that the delta degrees of freedom between the CFA and the baseline prep models should equal the number of marker items times 2. So the third model in our technique is called the baseline model. And then we're going to work off of the baseline prep model, and we're going to fix the covariances between the method variable and each substantive variable to 0, which I've highlighted for you there. And then we're going to run the model and copy the covariances to the from baseline worksheet that is in our workbook that we've provided. And again, make sure that you're getting 10 decimal places on these. It's very important. We're going to enter the fit indices into the models worksheet and the delta degrees of freedom between the baseline prep and the baseline should equal the number of substantive variables. Our fourth model is called method C, which stands for constraint. And the method C tests to see is common variance present. So we're going to build off of our baseline model and we're going to draw the paths from the marker variable to each substantive item, which I have put in red for you. And then we're going to constrain the substantive item factor loadings from the marker variable to be equal for all of my substantive variable items, which I have 21 of. So you'll see that I've constrained those by putting the letter A in the regression weight. We're going to run the model, enter the fit indices into the models worksheet, and the delta degrees of freedom between the baseline and the method C should equal the number 1, which is the number of common method variables. Method U is going to build on method C. This is our fifth model, and this is our unconstrained model. And it's going to tell us if we have common method variance, is the variance the same across all indicators? And so building on method C, all we're going to do on this one is remove the substantive item factor loadings from the marker variable. So there's nothing in red here because I just went in and removed the letter A that I put on my 21 substantive variable items. I'm going to run the model and then enter the fit indices into the model's worksheet. The delta degrees of freedom between method C and method U should equal the number of substantive items. So I have to stop there, and I need to look at my fit indices and model comparison before I can go on to method R, because method R is going to be build on either method C or method U based on whichever one has the better model fit. And in this case, looking very quickly, you'll see that method U has the better model fit. So my method R, which is my restricted model, it says, okay, I have common method variance, but does the presence of common method variance skew the relationships among the substantive variables? So in this case, since it was method U was my better fitting model, I'm going to build on method U, and I'm going to fix the substantive factor covariances to the values that we obtained earlier in our baseline model, which you'll see I've done here in red. We're going to run the model, enter the fit indices into the model's worksheet, and the delta degrees of freedom between method U and method R should equal the number of substantive correlations. So this is a really good time if you're going to work through Amos with me to pause the video and open Amos and load your data that you're going to be using. And as we go through the Amos portion, I will prompt you when it's a good time for you to pause the video and do a little bit of work so that you don't have to guess when you should stop, and you don't have to rewind and fast forward and all that stuff. So let's go ahead and pause here. Oh, this is my respecified measurement model from my structure equation model. And the first thing I want to do before I make any changes to this model is I want to save it as the name of my next model so that I will always have my measurement model without adding stuff and messing it up. I want it in its original format. So I'm going to call this CFA Marker. Okay. And then what I want to do is I want to add my marker variable, which is a latent variable that has 4 items. I'm going to view my variables in my data set so that I can name all 4 of my items, as well as I'm going to name my factor. And then I want to make sure that my errors are all named. So I name my unobserved variables, and I will clean all this up in just a moment. I also want to set the variance on each of my factors, marker variable as well as substantive. I want to set my variances to 1 on all of them, which means that I need to remove my regression weight that I have going from the substantive variable to the first substantive variable item for each item. Now I'm going to show you a really easy way to do this so that I don't overlook stuff, especially as this starts to get busy. I can do that in the tables. So I know I need all my variances set to 1. Okay, and then I want to make sure that all of my regression weights on my error paths are set to 1, and I can look through here really quick and make sure that they are all set. The Amos automatically set those for me. And then one more thing I need to do is I need to add the correlation between the marker variable and each of my substantive variables, because they were already there between my substantive variables. So I just want to make sure that I add them here. And now that I have all of that set, then I can I need to remove that. Needed to go back and remove all those regression weights. I could do that in the table, and then I can run my model once I get all of those. See, and this is, it tells me where to look, regression weights. So, and they're all empty now. So I've got all of them. So go ahead and run your model. So this is a good point for you to pause the video and add in your marker variable, make it look pretty, add in your correlations and your remove regression weights, add variances, get all of that ready and run your model. Let's open our text output. Now remember, it's very important that we have 10 decimal places, and I usually have my AMO set to 3, which you'll see right here. If I hover over, it says decimal. All I need to do is go in and change that to 10. I don't have to rerun anything. It automatically adjusted for me, as you can see. So what I need to do is get my unstandardized regression weights, which are right here, and I want to copy these. And I want to put them into the worksheet that says from CFA. And remember, I need to make sure these are 10. I can tell these aren't 10. My Excel makes me adjust it. So make sure that you check yours and go in and adjust it if you need to, or you're gonna have a problem later. And then I also need my variances. I want the title of that. And it's the same thing for these. I need to make sure that I'm getting the 10 decimal places. So I need to make an adjustment to that. And I'm really only going to be working with my marker variables on these. And so my marker variable errors are E28 through E31. I also need on my text, on my output, I need my model fit. Now I don't need 10. So this is completely user preference. I like to change them back to 3 when I'm looking at this. I need my chi-square, and I need my degrees of freedom. And I was trying to make my screen bigger and I made a mess. Here we go, model fit. So I've got a chi-square of 555.7. I have degrees of freedom of 265. I need my CFI. Oops. Which is point. In my RMSEA with my confidence interval reported as well, which is this. Help me out here. It's like I'm having technical difficulties all of a sudden. My RMSEA is You guys know how to do this, right? You don't have to watch me struggle through it. So I'm going to put 0.054, and then my low is 0.047, and my high is 0.060. So now that I have those recorded, I'm going to go on to my next model, which is my baseline prep. So what I want to do is I want to save my CFA model as my baseline prep, so that as I build on my baseline, as I build on to my CFA model with my baseline prep, I am not losing anything. So what I do in my baseline prep is I'm going to add my regression weights and my variances that I've just copied into this from CFA worksheet. And again, the easiest way to do this is going to be to go to my tables, because these are going to be really big numbers. Remember, I have 10 decimals. And this is really cool. What I like about doing this is that I know these are my regression weights. So if I come on to my table, I don't have to guess where all this stuff goes. It tells me regression weights. So I know I'm going to go to B4, and I'm going to type in this number or copy and paste it, so on and so on. Okay. Make sure that my error is still at 1, that my regression weight for my errors is still at 1. That's very important. And then this column says variances. Well, if I go up here, this says variance. So I'm going to take my values from down here, and I'm going to put them in right over here. Okay. Then I am going to run my model. This is a good time for you to pause and do those steps, and then run your model, and then start the video again. Let's view the text output. And remember, I changed my decimals to 3. I needed to change those back to 10. Actually, you know what? That's not true. On baseline prep is just a stepping stone between the CFA and the baseline to make sure that I don't miss any steps. And I'm not even going to report this in my article. So I'm just going to go to model fit, and I only need the degrees of freedom and my chi-square. And I'm going to put them on my baseline prep, which I've done here. The delta degrees of freedom between my baseline prep and my CFA should be the number of marker items times 2. My degrees of freedom is 8. I have 4 marker items, so I know that I'm tracking right with that one. Okay, so now I'm going to go on to the baseline. So I'm going to save my baseline prep as my baseline. And on my baseline, now what I'm going to do is I'm going to I'm going to fix the covariances between my marker variable and my substantive variables only. I'm going to fix those to 0. And again, the easiest way to do that is going to be to go to my table, go down to covariances. Now, the 0 doesn't show up, but I like to put it here that first time anyway, so that I can make sure it's there. So on everything that says marker item, see, it's already popping up. I want to make sure that I have a 0 there, and there should only be 4 of them, so they're all there. And I can run my model now. This is a good time for you to pause the video and set your covariances to 0. Let's view our text output. Now I do need to set my decimals to 10 because I'm going to capture my covariances. right here to use in a future model. So I'm going to copy these and I'm going to put them on the worksheet that says from CFA. I've already put those there. Wrong one, from baseline, sorry. But I have already put them there. And so make sure that I have 10 items here. And I'm going to only be using my substantive variables. Then I'm going to go back to 3 because I'm done doing that. I want my little numbers back. And I'm going to capture my model fit. So my chi-square, my degrees of freedom, on my models. So my baseline, my chi-square is 576.1. My degrees of freedom are 277. My CFI is 0.942. And my RMSEA with my, with my confidence interval of 90% is 0.053, and then 0.047 is my low, and then 0.059 is my high. And what I want to look at now is, in checking my work right here, my degrees of freedom between baseline and baseline prep are 4, and that should represent the number of substantive constructs that I have, which I do have 4: AD, RC, ITS, and HD. So I am still tracking correctly on here. So my next model is going to be my constrained model, my method C. So I want to save this as my constrained model, and this one's busy because what I'm going to do is draw a path from my marker variable to all 21. I have 21. I don't know how many you have, but to every one of my substantive variable items. And that's very busy. And then I'm also going to constrain those 21 paths, and to constrain them to be equal, I'm just going to use the letter A. So once I've drawn all of these, I need to go into my table and make sure that I didn't overlook any. And I'm going to do that by, you see how all these say marker variable? Okay. So I had A1 through 9. Check these. I had H2, I skipped H1 and 4, and those went to 9. And then I had ITS 1, 2, 3, and RC 2 and 3. So all of my paths are drawn, and I want to make sure that I constrain all of them to A, which I can confirm that right there. Isn't that a lot easier than looking at this and trying to click on these? See, I didn't even click on the right one, especially when you get in here where some of these are going from the substantive variable to the item, and these are trying to go from the marker variable to the item. It gets very confusing. So I'm ready to run my model. This is a good stopping point for you to take your time and draw your paths and constrain those paths to be equal, and then run your model and start the video back up, and we'll talk about the output. Let's view text output. On Model C, I'm just going to go straight to model fit because this is what I need. I need my model fit. So my chi-square is 571.1. My degrees of freedom are 276. My CFI is 0.93. And my RM SEA with confidence interval is 0.053, low of 0.047, and high of 0.05. And what I'm looking for here in checking my work is that my delta degrees of freedom should be equivalent to how many common methods I have. And I only have one. I know that. That's my blue attitude right here. So I'm still tracking on with that. So my next model is going to be my method U. So I'm going to save this as method U. I'm going to close that text output before I get confused. So on my method U, the only difference here is that I am removing that constraint that I just added on these paths. So I'm going to go into my tables and I'm going to remove the A I just added on all of those. Very simple, just delete them all. And then I'm ready to run my model. This is a good stopping point for you to remove your constraint. Okay, let's view our text output. Model fit. We need our chi-square, 538.9, our degrees of freedom of 256. The difference between our degrees of freedom, and I believe I made a note on the PowerPoint, and the formula is already set in here for you, so don't worry about this. But if you lose the formula out of Excel, this should actually be the difference plus 1, because obviously that's 20 and there's 21, and we know that there's 21 substantive items because I'd already counted them because I needed to make sure I had enough lines going to my items. I need to add my CFI, which is 0.946, and my RMSEA with my 90% confidence interval. Okay, now when I go to method R, my restricted method, I am going to base that on either method U or method C, depending on which one has the better model fit. And you will see that the formulas have already been put in here for you. So I didn't type these numbers, they populated for me. So when I'm comparing my method C and my method U, I'm looking over here, and I can see that my method C is significantly different from my baseline model. Okay, that's good. I can't rule that one out. And my method U is significantly different from my method C, so I can't rule that one out either. So we're going to look at our fit indices. Well, method U has a smaller chi-square, which is favorable. I've lost some degrees of freedom, but since I'm significantly different than method C and method U, that's acceptable. I want the larger CFI and I want the larger RMSEA. So based on this, I'm going to say that my method U is a better fit, and I hope you agree with me. So what I'm going to do is go back out to Amos here, and I'm going to take method U, and I'm going to save it as method R. Had method C been the better fit, then I would be saving method C as method R. And what I'm going to add in method R is I'm going to add the covariance between my substantive factors that I obtained in my baseline model. From baseline, these numbers here, remember they have 10 decimals. And again, the best way to do that is to go into my table, bring this up, and my covariances are all the way at the bottom. Where it says covariances. So I'm going to take these numbers and put them into here. Okay. Then I am ready to run my model. So this is a good stopping point for you to get ready to run your model. Let's view our text output. Model fit. And let's fill in our fit indices here. Our chi-square, 539.4. Degrees of freedom, 262. So our difference in degrees to freedom are 6, which should be equal to the number of substantive correlations. And I can check that on my table here. We're going down to correlations and counting them. I have 1, 2, 3, 4, 5, 6. Very good, I'm on track. This is populated for me. I put in my CFI, 0.947, and my RMSEA with my 90% interval, and I've got that in there. So that concludes the portion that we're going to run in Amos. Now we're going to take the model, and I've provided you a worksheet as well of what you would actually, how it would look for you to fill this in and to copy and paste it into your article. So now we're going to look at this, because what we want to do is complete our table and then write to our findings based off of the table. So let's take a look at the table and what does all of this mean so we can report our findings. What does all this mean? Let's do a quick refresher from what we talked about at the beginning. If method C does not fit significantly better than the baseline model, then there's no evidence of shared common method variance. If method U does not fit significantly better than method C, then common method variance is the same for all indicators. And if method R is significantly different than method C or U, depending on which model you built your restricted method on, then the presence of common method variance skews the relationships among the substantive variables. So let's take each of these three definitions and look at each method in the table that we just built. So we're going to start with method C, and we can see by our p-value of 0.025 that method C fits statistically better than the baseline model, which indicates the presence of common method variance. We can see by method U, if with the p-value of 0.041, that method U fits statistically better than method C, indicating that the presence of common method variance is not the same for all of the indicators. And we can see with a p-value of nearly 1 that method R is not statistically different than method U, indicating that the presence of common method variance does not skew the relationships between the substantive variables. Okay, so now what do I do with that information? As with a lot of statistics, this is my judgment call. And I believe that since yes, I did find a little bit of common method variance. I don't know how much, but I do know it wasn't consistent across all indicators, and I know it did not skew the relationships in the substantive variables, which is ultimately what I was checking for. So I choose, as the researcher on this project, to report these findings by pretty much just stating what I just put on the right-hand side of these 3 slides, so that I'm transparent. And I've said, hey, this is a rigorous study. I knew there was a possibility of some common method variance, so I put a latent marker variable in there. I tested for it, and this is what I found. So I would report this, and then I would just move on. That would be the end of this portion, the common method variance portion of my article. Now, what if method R is significantly different? Then I would refer you to the citation at the bottom of the screen and tell you that Williams et al. 2010 does a really good job of walking you through the steps that you would want to take if you were going to pursue your common method variance a little more. Maybe that you found that based on your method U, on your method R, that, oh my gosh, it does skew the relationships. So the first thing that I would want to do is my reliability decomposition, because that will tell me, it will quantify the amount of method variance. If a judgment call, does this really distort my findings? Another model I would run would be my sensitivity analysis. And the sensitivity analysis is actually 2 models that are ran based on using different confidence intervals. And that analysis would tell me if the variance that I'm seeing is due to sampling error. So once I've run these 2, then I can report these findings with my other findings. It just takes it a little bit farther for me to explain what's going on in my study. These are the 6 references that I used in this presentation, and there are also 6 amazing journal articles that I recommend that you download to further your understanding of common method variance. My hope is that I've inspired you to consider a marker technique in your study. And if your research method applies structural equation modeling, I encourage you to take a look and see if the CFA marker technique fits for you in your study. I wish you the best of luck in your scholarly journal, and if I can be of any help to you at all, I've included my email address at the bottom of this slide, and I encourage you to reach out to me. Or if you run across some awesome journal articles yourself then that you think I would benefit from, go ahead and share those with me. It would be much appreciated. So good luck, everybody.